Hello, my name is Terry Chang, and today I'm going to teach multiply whole numbers. The first thing we'll learn in this chapter is use multiplication notation. Suppose you were asked to count all these pennies. Will you count the pennies individually, or would you count number of pennies in each row and add that number 3 times, like 8 plus 8 plus 8? Multiplication is a way to represent repeated addition. So instead of adding x 3 times, we could write a multiplication expression like this. So we call each number being multiply a vector and the result the products. We read this as 3 times x, and the result as the products of 3 and x. Next, symbol of multiplication. There are several symbols that represent multiplication. These include the symbol x as well as the dots and parentheses. Now you can try to translate from math notation to words. For these 3 questions, I will give you like 30 seconds to answer it. Okay, I think time's up. The answer for the first one is 7 times 6. For the second one is 17 times 4. And for the third one is 6 times 4. Next, model multiplication of whole numbers. There are many ways to model multiplication. Unlike in the previous section where we use base and blocks, here we will use counters to help us understand the meaning of multiplication. A counter is any object that can be used for counting, and we will use round blue counters. For example, model 3 times 8. To model the product 3 times 8, we will start with a row of 8 counters, and then the other factor is 3, so we will make 3 rows of 8 counters. Now we can count the result. There are 24 counters in all. Like 3 times, so we know 3 times 8 equals 24. Next, multiply whole numbers. In order to multiply without using models, you need to know all the one-digit multiplication facts. Make sure you know them fluently before proceeding in this section. So just remember the table in the bottom, and you can take down the notes for you. Now you can try to multiply 0 times 11 and 42 times 1. For these two, I will give you 10 seconds to answer it. Okay, time's up. The answer for the first one is 0, for the second one is 42. Just remember, the products of any number and 0 is 0. The products of any numbers and 1 is the number. Next, commutative property of multiplication. Earlier in this chapter, we learned that the commutative property of addition states that changing the order to addition does not change the sum. We saw that 8 plus 9 equals 17 is the same as 8 plus 9 plus 8 equals 17. So is this also true for multiplication? The answer is no. The answer is yes. 7 times 4 equals 28, and 4 times 7 equals 28. 9 times 7 equals 63, and 7 times 9 equals 63. So changing the order of the factors does not change their products. So A times B will equal B times A. To multiply numbers with more than one digit, it is usually easier to write the numbers vertically in columns, just as we did for addition and subtraction. We will start by multiplying 3 by 7. So here are the two 10 in like 7 times 3 equal 21. So here is the 1 in 21 and two 10s in the 21. And next, 2 times 3 equal 8, so sorry, 2 times 3 equals 6, and we plus the 2, so it's 8. So we can now let 27 times 3 equal 81. Next, you can try to multiply 15 times 4. And for this one, I will give you like 30 seconds to think about it. I think time's up. So answer is 60. So like 5 times 4 equals 20, and 4 times 1 is 4, so 2 plus 4 is 6. Next, try to multiply 62 times 87. It's a little bit harder, so I will give you like 40 seconds to answer it. I think time's up. So the answer, we times it first. That 2 times 7 is 14, so 4 in the bottom, 1 in the top. And then 6 times 7 equals 42, so we add 1 is equal 43. And next, for the next row, 8 times 2 equals 16, so just remember it's in the tens, so we have to add 1 0 in the ones. So 8 times 2 equals 16, 6 in the bottom, 1 in the top. Then 6 times 8 equals 48, and plus 1 equals 49. And finally, we add the 434 with 4,960 together. So the answer is 5,394. Next, translate word phrase to math notation. Earlier in this section, we translated math notation into words, and now we will reverse the process and translate word phrase into math notation. Some of the words that indicate multiplication are given in the table below. So like times, products, or twice. 3 times 8, the products of 3 and 8, and twice 4. For twice 4 is 2 times 4, because twice means like double it. And 3 times 8 is like x dot parentheses. And the products of it is like you can change the like 3 to 3 times 8 or 8 times 3, it doesn't matter. And next you can try to translate and simplify the products of 12 and 27. For this one, remember to find out the answer and then translate it. For this, I will give you 30 seconds to answer it. Okay, I think time's up. The answer is 12 times 27, and to simplify it is 324. Next, again to translate and simplify. 12 211. For this one, I will give you 20 seconds to answer it. Okay, I think time's up. To translate it is you can write that that's 211 or parentheses or the x. And next, the answer is 422. Multiply whole numbers in applications. We will use the same strategy we used previously to solve application of multiplication. First, we need to determine what we are looking for, and then we write the phrase that gives the information to find it. We then translate the phrase into math notation and simplify it to get the answer. Finally, we write a sentence to answer a question. So now, just following the step, you can try to answer this question. Humberto bought 4 sheets of stamps. Each sheet had 20 stamps. How many stamps did Humberto buy? For this one, I'll give you 40 seconds to answer it. Okay, I think time's up. First, we write the phrase, the products of 4 and 20. Then we translate it to math notation, 4 times 20. And we subtract 4 times 0 is 0, and 4 times 2 is 8. So answer of 4 times 2, 20 is 80. Then we write a sentence to answer the question. Humberto bought 80 stamps. And that's the end. Thank you for listening.